In this lesson, we'll be graphing linear inequalities and solving absolute value equations. To start graphing linear inequalities, let's go through the steps. First thing I want you to do is to solve for y and identify the slope and the y-intercept. The next step is to graph the line by plotting the y-intercept first on the y-axis and then use the slope to get more points. And that's rise over run. If you have a less than or equal to sign or a greater than or equal to sign, you're going to have a solid line. If you have a strictly less than or a strictly greater than without the little line underneath it, you're going to have a dotted or dashed line, however you want to say it. So step 4 says to shade above the line if the equation is greater than, like y is greater than mx, greater than or equal to mx plus b, or y is greater than mx plus b. Greater would be above. That kind of makes sense. Shade below the line if the equation is less than. For example, y is less than or equal to mx plus b, or y is less than mx plus b. So below, above the line is where you're shading it, and solid or dotted if you have or equal to or strictly less than. So on this first equation, y is less than negative 3x plus 2 is already in the correct form, slope-intercept form. So my slope is negative 3 and my y-intercept is 2. So I'm going to plot my 2. And then that's my y-intercept and my y-axis. And then I'm going to move my slope, or negative 3 over 1, which is down 3, right 1, down 3, right 1, down 3, right 1. Another thing I could do is go up 3 and left 1. Going all the way off my graph gets me a really long, beautiful line. I'd like to decide if I'm going to be solid or dotted, and because it's not equal to, it's going to be dotted or dashed, whichever word you like better. So you're going to draw a broken line here, a dashed or dotted line here. And that is the boundary line of where all the solutions are and where there aren't. So now I've got to decide where I'm going to shade. So because it's y is less than, then I'm less than tells me I'm going to shade below. When the slope is real steep like it is on this problem, sometimes people have a hard time deciding which side is above or below. But if you take any point, like let's say the point on the y-axis, and you go straight down from it, you're going to end up in one side, which is the lower side here. I know it kind of looks like it's to the left, but I need you to think of it as always above or below the line because we're comparing it to y. Y is less than. That's why it's either above or below. It's not left or right because we're not comparing it to x, we're comparing it to y. My next equation is also in slope-intercept form. Y is greater than or equal to 2/3 x minus 1. And in fact, right now I can decide, even before doing anything else, I can decide that because it's or equal to, this is going to be a solid line. And because it's y is greater than or equal to, that is greater, which means I'm going to shade above. Even before doing any of the problem, I can already decide I know it's a solid line and I know I'm shading above. So to get the boundary line, I'm going to look at my slope, which is 2/3, and my y-intercept, which is negative 1. So I have a negative 1 there, and I'm going to go up 2, right 1, 2, 3, up 2, right 1, 2, 3. Or I could go down 2 and left 3. I know that's going to be a solid line. We've already talked about that because it's greater than or equal to. Okay, the way I remember that is that line underneath it is the decider, right? If there's a line underneath, then that's like your solid line. If there's no line underneath, that means it's a broken or a dashed line. That's just something that I'd use to remember. And then I've already decided that because it's greater, y is greater, I'm going to be shading above. So if you take a point and go straight above it, you can clearly see that this side is the above side. Shade it in with the side of your pencil. Yours will probably look nicer than mine. On these next problems, they're not in slope-intercept form just yet, so I need to spend a little bit of time putting in a slope-intercept form. So I want the y in the front, so I'm going to move the y over here, so that gets me 4x plus 3y is less than or equal to 12. And I also want the 4x on the other side, so that's positive 3y is less than or equal to. When the 4x gets moved to the other side, it changes sign, mean negative 4x. And then I'm going to divide everything by 3. So my equation is y is less than or equal to, my sign doesn't change because I didn't multiply or divide by a negative, negative 4/3 x plus 12/3, which reduces to 4. Because it's greater than or equal to, that tells me I have a solid because it's or equal to, and because y is less than or equal to less than tells me I'm going to shade below the line because I'm comparing it to the y. So I'm going to plot it for my y-intercept at 4, use my slope of negative 4/3, which is rise over run. So I'm rising negative 4, which is down 4, and running 3, which is positive 3. Repeat that. I could go up 4 and left 3. That is also in the negative direction. We said that we're going to have a solid line, so I'm going to continue to draw a solid line here. Don't forget your arrows. And y is less than says I need to shade below the line. Which means everything in the shaded region is a solution to the inequality. If you choose any point on the shaded side and plug it in, it should work. On the next problem, I'm going to get the y all by itself, so it's in slope-intercept form. If I move the positive 3y to the other side of the equation, that becomes negative 3y. And I'm going to subtract 9 or move it to the other side, and that becomes positive 4x minus 9. And lastly, I'm going to divide everything by negative 3. So that gets me y is, because I divided by a negative, my sign changes. Y is greater than negative 4/3 x. Negative 9 divided by negative 3 is actually plus 3. The sign changes here. Now it's important to solve for y first to decide if it's greater than above the line or less than below the line. This is a greater than or not equal to. It's not equal to, so I know this is a dotted or dashed line. And because it's y is greater than, that's going to be a above the line. My slope is negative 4/3. My y-intercept is 3. So I go to 3 and I put a dot there. My slope is negative 4/3, which is down 1, 2, 3, 4, right 3, down 4, right 3. Or I could go up 4 and left 3. I've already decided that I'm going to have a dotted line, which means I can't include the line. And this says y is greater than, so I'm shading above the line. So anything in the shaded region, but not including the line, is a solution to this inequality. Now these next two are special cases because they only have one letter. So this is either going to be a Hoy or a Vux problem. The first problem is y is greater than, so that's a Hoy problem. The next problem has only an x, so that's a Vux problem. So a Hoy problem tells me that I have a horizontal line so I have y is greater than or equal to 4. My m this could be like 0x plus 4. My m is 0 and my b is 4. Or you could just know that there's a 0 slope using your Hoy. So I put my pencil on the 4. Is this a solid or dotted? Well, because it's or equal to, it's going to be solid. So I can just draw a solid horizontal line at 4. And now I'm going to decide if I'm shading above or below. It says y is greater than. Y is greater than, so I'm still shading above. Because I'm comparing to the y, it's above or below, because y is a vertical direction, so I'm shading above your line. Now, any value in this shaded area or on the line is a solution to the equation y is greater than or equal to 4. Now on the next problem we have a Vux problem, which tells me that this is a vertical line. Because it's a vertical line, you can't put it in slope-intercept form. That just doesn't make any sense. So we're going to just use x is less than -2 for our equation. My slope is going to be undefined. And my y-intercept, there is none, because you can't have a y-intercept on a vertical line unless it's already on the y-axis. So to plot this, I'm going to go to -2. Is it a solid line or a dotted line? Well, because there's not or equal to, that means it's a dotted line, or a dashed line, whatever you like. So do your best to draw a dashed line there. And because we have x is less than, okay, now this is different than all of the other problems. All of the other problems were y is greater than or y is less than. So we shaded above or below, because when you're comparing to y is a vertical direction, so you're either going to be shading above if it says y is greater, or shading below if it says y is less than. But because we're comparing to x here, not y, we're comparing to x, we're either going to be shading to the left or to the right. So x is less than is going to be to the left. So this is the one case that you don't have above or below because you can't compare to y. So we have left or right. But if you think about this in terms of a linear equation in one variable instead of in two, if I asked you to graph x is less than -2 on a number line, you'd put an open circle at -2 because you're not allowed to equal it. The open circle is very similar to the dashed line. The closed circle would be a solid line. And you'd point your arrow to the left. So it's basically the same thing here. If I put it right there on my number line, it's every value to the left of -2, not including the line. So that's why we go left. It is very similar to a linear equation of one variable.